So we've got the geometer. Well, last year I put the picture under it, but I think I'm going to go ahead and draw the picture. You actually have one. Let me do this. Got some algebra 2 right here. Okay, you've got one, and they're labeled. You've got one right here, and you've got one right here. Now, the skinnier one, sometimes it's a tougher one just because it's kind of long and skinny. And this one probably is the more popular one. I know I'm going to use that one, and I might use this one. So they're labeled right here on your geometer. We're going to use this one first. So let's go ahead and draw it. And go ahead and draw its diagonals. I think people have a little bit of trouble with a rhombus because it's not usually something that you talk about much in elementary school. You know, you'll teacher will hold up a figure, little kids like, oh, that's a rectangle, you know, that's a triangle. But I don't think rhombus is probably one of those. You know, it looks like a parallelogram because it actually is in the parallelogram family, but a rectangle is too, and a square is too. Before we start marking things, we need to make sure that all parallelogram rules apply. Now, it is not a rectangle, so the rectangle rules don't apply. And I'll show you that. I think I showed it to you the other day. Remember? Did I show you this? I'll get you one when we do squares. All three of these are parallelograms. And so we had our rectangles that are parallelograms that have their two little extra rules. And then rhombi are parallelograms and have their three extra rules. And then we'll pick up squares. And even though they look like they've got a lot of rules, most of those you probably already know anyway. So, what do we want to say first? Extra rules. What did we say the other day? We said 2 more rules, so now we'll put 3 more rules. Now, this is not a great way to say it, but it makes it easier if you think about it. All sides are, and I'm just going to use the symbol, congruent, because I didn't even put a name to this when I drew it in my notes last year. So all sides are congruent. Now here's the way I picture it. It's not a good description. All squares are rhombi. Okay, a square is always going to be a rhombus because it has this characteristic. All the sides are the same. But if you just look at the picture, a rhombus, you know, because when you just look at that, you go, well, that's just a parallelogram. But it's a special parallelogram because it's like a square pushed over on its side. So all the sides are the same. So let's mark that. Okay, so now if you know one side, you know all of them. And this is one some people struggle with. Number 2 is the diagonals are perpendicular. What does that mean? What's perpendicular? I wrote the symbol. I didn't write the word. Do I need to write the word? Perpendicular. Oh, little children, what is that? Okay, perpendicular. So all of these are right angles. Now, if you want to mark it, I just usually mark it one like that, but they're all 90 degrees. So all of those are 90 degrees, and I'm going to tell you a big thing that's going to come up in just a minute. And then the other one, and this is the one that most people forget, is diagonals bisect. There's another word. Don't make me look this one up. Opposite angles. Okay, let's back up to parallelograms just a little bit. Remember, opposite sides congruent, opposite sides parallel, opposite angles are congruent. So all of this angle is congruent to all of this one, all of this angle, and you will have an obtuse one and an acute one, and all of this one's going to be all of this one. But what does it mean if this is going to bisect an angle? What's that going to do right here? Bisect. We bisected a segment. Didn't we bisect a segment over here somewhere? Diagonals bisect each other. Number 5 rule. It made these two segments congruent, these two segments congruent. So what about bisecting angle? I know we did this construction, so I could flip back to that real easily. What are you going to have? You take an angle and you bisect it. What you going to have? Ooh, y'all wearing me out today. Man, look at there. We did angle bisector. I didn't have my rules glued on here. What did we do? We took an angle and we made what? Two angles that are the same, congruent. Bisect. Bisect cuts something in 2 equal parts. So this one's going to be congruent to this one. Now here's the biggie. It's going to be congruent to this one. It's going to be congruent to that one. So here you're going to have, you know, say it's 30 degrees, 30, 30, 30, 30. We love that. Same thing's going to happen up here. This one's going to be the same as, am I on screen? Is the same as this one, is the same as this one, is the same as this one. So the arithmetic is easier, which is kind of weird. The arithmetic is easier the more rules you get. And then you have right angles. Now I can tell you where you're going to, you know you have Pythagorean theorem on rectangles with one of the big triangles. Somebody yesterday was talking about like one of these triangles right here. You know, these two triangles are congruent. They are isosceles triangles. This one's isosceles, this one isosceles, but those are never going to be right triangles. Never. Just as a rectangle. Square, yes. Rectangle, no. So here, you only have right triangles in the corners. But here, you have, look, you have 4 right triangles. See, because all of these, and they're all congruent. Because if you go back, diagonals bisect each other because it's a parallelogram. So this little piece is equal to that little piece, and this little piece is equal to that little piece. You have a long diagonal and a short diagonal. Go by the pictures. That helps a lot. Just to physically, that's why I like to use the geometry.